Hello viewers, I am Kausalya. Today we are going to solve problems related with coupled circuits. So here the problem is calculate the current in the 5 ohm resistor for the coupled circuit shown. So here this is a given circuit diagram, right? There are two loops, right? Let I1 be the current that flows in first loop and I2 be the current that flows in the second loop. And here this J4 denotes the mutual inductance that exists between these two loops. And here we are having a source voltage of 50 volt in the first loop, right? So here we are requested to calculate the currents I1 and I2. So as usual, here first we are writing our loop equations by applying KVL. So what is KVL? Sum of voltage drop in a circuit is equal to sum of voltage rise in the circuit, right? So here, when you look at this loop, right? So here what is the voltage rise? It is 50 volt. So 50, right? And what are the voltage drops? The voltage drops are those that occur across these elements, right? So here I1 is the current that flows through this path. Therefore, 2 plus J5 into I1, right? Plus, here the mutual inductance value is J4 and that mutual inductance is because of the current that flows in the second loop, right? So, J4 I2. So here why we are using a plus sign? Because you see in the first loop, the dot is placed at the point where the current enters this inductor, right? In the same way, when you look at this loop 2, again the current enters in the path where there is a dot, right? So in both the loops, current enters in the path where dot is present. So therefore, the mutual inductance is said to be plus here. Right. So now we move to the second loop. So the second loop doesn't have any sources here. Therefore, it is 0. And again, voltage drop is 5 plus J10. The current that flows here is I2. Therefore, 5 plus J10 into I2. And again, due to mutual inductance, we are having plus J4 due to this current I1. So, plus J4 I1. Right. Again, we are rewriting these two equations in matrix form, right? So here 50 is 0 and here the coefficient of I1 is 2 plus J5 and here coefficient of I1 is J4 and similarly here J4 and 5 plus J10 multiplied by respect to I1 and I2. So as usual by Cramer's rule, we are going to find the values of current. So the first step is we are calculating delta. So delta is nothing but it is the determinant of this matrix. So when you take the determinant value and you solve, you see here we are finally ending up with minus 24 plus J 45. So the next thing is we are going to calculate del 2 because we are requested to find the current that flows through the 5 ohm resistor, right, which is present in the second loop. So del 2 is nothing but you have to replace this second column by the source voltages, right? So just replace it and again when you find the value it is minus J 200 here. Now what is the formula for I2? I2 is nothing but del 2 by del. So the value of del 2 is minus J 200 and what about the value of del? It is minus 24 plus J 45. Right. So these two terms are in rectangular coordinates. You can directly solve by using a calculator. Right. You can keep the same values as such and you can solve and find the answer using a calci. But here what I have done is I have converted these rectangular coordinates into polar form. Right. Once you convert this into polar form, you can directly do this. That is 200 by 51 is nothing but 3.921. And again when you shift this angle to the numerator part, this positive angle becomes negative, right? So again, so when both the angles are with a negative sign, we can add, okay? We have to put a minus sign, but we can simply add. So here, this is the value of current that flows through that 5 ohm resistor, right? So in case if the value of I1 is asked, again what you have to do? When the value of I1 is asked, you have to write it as I1 is equal to del 1 by del, right? Just find out the value of del 1, just substitute it and find out the value of current in the same way here, right? So here comes the end of this problem. We will proceed with the next one. So our second problem is calculate the phasor currents I1 and I2. So here this is a given circuit diagram, and again here we are having a mutual inductance of J3 ohms. Right. So what about the sign of this mutual inductance? Again you look at this loop I1, current enters in this path. Right. So dot is at the entering point of current. But whereas when you look at this loop 2, you see current enters here and leaves here, but here the dot is present at the leaving terminal. Therefore a dot is present. Therefore since the dot is present here, so here what about the mutual inductance? Whether it is positive or negative. Here it is present in the entry point of current, whereas here it is present in the exit point. Therefore they are opposite to each other. So here we have to include a minus sign. Right. So again by KVL we are writing our loop equations. So here you see voltage drop is nothing but minus J4 plus J5 multiplied by I1. Right. And minus the mutual inductance is minus J3 I2, which is equal to here the voltage rise is 12. Right. That is source voltage. Again when you look at this loop 2, what happens? So same thing, J6 plus 12 into I2 minus J3 into I1, right, which is equal to 0 because in the second loop there is no source voltage, right. So the next thing is, again we are writing this in matrix form. The same thing, coefficient of I1 is this and coefficient of I2 is this. So write it over here. Similarly, coefficient of I1 is this and I2 is this. I1, I2 which is equal to 12 and 0, right. So here it is multiplied, right. So again when you solve, you see I am having minus J4 plus J5, therefore it becomes plus J. So remaining things, they remain the same. So the next thing is we have to find del. So the value of del is, you have to take the determinant of this part, right. So while taking determinant, I am sure that you know J square is minus 1, right. You always keep this in mind. J square gives you minus 1. So keeping this in mind, you just simply solve and we are getting the value of del as 3 plus J 12, right. The next thing is we are going to find the values of del 1 and del 2. So how to find the value of del 1? You have to replace the first column by source voltage, right. So here we have replaced the first column with the source values, and finally the value of this del 1 is 72J plus 144. Now the next thing is finding del 2. Again you have to replace this second column by the source values. Just calculate the values, and here the value of del 2 is J36. Now we are going to find the values of I1 and I2. So the value of I1 is del 1 by del. So here this del 1 is this one, okay, 72J plus 144, and the value of del is 3 plus J12. Again the same thing, you can directly solve this in a calculator, or you can convert this rectangular coordinates to polar form and you can solve, okay, it is up to you, right. The answer will always remain the same. So here this rectangular coordinates are converted into polar coordinates here. So 160.99 divided by 12.369 gives 13.01, and again when I shift this 75.96 to the numerator, this positive angle becomes negative, right. So when you subtract here, that gives the answer as minus 49.39 degrees, right. Now the second thing is the value of I2 the same way, del 2 by del. So the value of del 2 is J36, the value of del is 3 plus J12. So again when you solve, we are ending up with the answer like this. So here comes the end of this video. If you have any doubt, let me know in the comment section. Here the key things you should be familiar is, the first thing is you should know how to assign the sign of mutual inductance, right, either plus or minus, you should be clear with that. Then the next thing is, since here we are having J term as a common thing, that is what to say, while multiplying or doing some calculations, be aware, okay, be aware of whenever you are coming across J values, okay, be alert, little bit alert, right, because these are the places where we will make mistakes unknowingly. So that's all. If you have any doubt, let me know in the comment section. Thank you.